So in this lesson, we're going to have a look at how we can solve quadratic equations when we're not able to factorise them. We will be using something called the quadratic formula. So to use this formula, we need to be able to substitute the coefficient values, and what I mean by that is the numbers in front of your x squared, x, and your constant term in your quadratic expression. We will also be using our rounding skills to round our final answer to possibly either decimal places or significant figures. You will be using your thinking skills to do this, and organisational skills are very, very important. And when we do some problem solving later on in this topic, you will also need to use your communication skills. All of this quadratic topic we've mentioned before has got lots of practical applications in computer science, physics, healthcare, education, as well as in engineers, civil engineers, people like that definitely use all this work that we are currently doing. So for yourselves, using the quadratic formula, this is what you're being introduced to. So it's about learning that some expressions do not factorise. It's usually a bit of a giveaway in a question about when to use this formula, because it will usually say solve, gives you the quadratic equation, and then it will indicate that it's going to be to decimal places. So to solve a quadratic equation which doesn't factorise, this is going to be the formula here that you're using. It's this big complicated one. If you've been looking at your National 5 exam papers, this one is the very first formula that appears on the sheet. What it does look pretty complicated, but what it refers to, the A, you'll notice on this side, you've got A's, B's and C's. What the A, B and C refer to is the number in front of the x squared is your A, the number in front of the x will be your B value, and the C value will be the constant at the end of that. This bit here, what this means, the plus and the minus together, basically that is just a way of not print, it's a shorter way of writing out the formula. You do actually get two different roots, and one of them you will be adding the square root value, and the other, to get your other solution, you will be subtracting the square root value. So it actually splits up into two, even though it looks quite complicated when it's set out this way. So your A, your B and your C are simply the numbers in front of your x squared, x and constant. So let's have a look at how we do this in practice. So it's quite, my suggestion is that you use the opposite page, the back of the previous page, to put all your work in for this, because it is quite complicated. You are looking at this expression here, this quadratic, x squared minus 5x plus 3 equal to 0, and you are having to compare it to the standard format, which is ax squared plus bx plus c equal to 0. And from that, you are identifying what the a, the b and the c are. So a is whatever is multiplying x squared. If there's no number written there, then the 1 is implied. For the b value, you've got the negative 5 going on there. So make sure you write the negative in, and for the c, that doesn't have x, so you're going to have c equals 3. Now, rather than go straight to subbing into that big complicated looking expression, we're going to work out the bit that's under the square root first, because this is one of the values, one of the marks rather, is given for the value of this. So it's quite important that you do this correctly. Now, when you're using your calculator, please make sure that, because it's b squared at the front of this, and that's a negative number for b, make sure you put the brackets in. So it needs to look like that, negative 5 squared. This is then going to be minus, and that 4ac means that you're doing 4 times the a value, right, times by the c value. And if you do all of that on the calculator, that comes out to the value of 13. And that would be one of your marks, that would be your first mark. But that's only a wee bit of it. Remember, all we've done so far is work out the bit under the square root. So what do we know? Right, we know that the roots of this equation, right, are given by that big formula. So x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. Right, that's what appears on the formula sheet. We're now going to substitute into that, so we're going to write down x equals, now it's going to be negative b, but our b is already a negative, so it's like negative of negative 5. We've got the plus and minus the square root. Now we've already just worked out what b squared minus 4ac is. We know that that is 13. And on the bottom, right, that is, make sure that line goes all the way across, and you're doing 2 times a, and our a value is 1. Now this double negative bit here, negative of negative 5, means that that's actually going to be positive 5. So this is what we've got, 5 plus and minus the square root of 13 all over 2. And it's at this point that you split it into your 2 roots. Now if you're using a fraction key on your calculator, then press the fraction key so that you can do that, 5 plus root 13 over 2. And the other root will be 5 minus root 13 all over 2. If you do that correctly, then, and use my advice is you use the fraction key to do that, then what comes up on your display, right, is x equals 4.3027, whole load of other figures, but we were told that we had to round to 1 decimal place, so that would mean your answer for that one would be x equals 4.3, and for this other one, if you do that on the calculator, you get 0.6972, whole load of other figures, and again round down to 1 decimal place, this one would be 0.7, and that would be your 2 roots. So make sure when you do this that you're following through the process that I've got written out there. So let's look at the second example. So, and again, possibly do this on the opposite page. So you've got your equation 2x squared plus 6x minus 7 equals 0. You are comparing that to ax squared plus bx plus c equals 0. So in the first instance, identify your a, b and your c. So here your a would be 2, your b is positive 6, and your c this time is negative 7. So you need to watch that you're paying attention with the positives and negatives. We're going to work out the b squared minus 4ac bit first. And that means when we sub into this, we get 6 squared minus 4 times our a is 2 times by the c value is negative 7. Now just do all of that on the calculator. That should give you 92. Right, now we're ready to work out the roots because we've worked out that first little bit on its own. So remember, right, that the roots are actually given by this expression x equals, and you get this from the formula sheet, x equals negative b plus and minus root b squared minus 4ac all over 2a. So that whole line goes all the way across. Now we're subbing in. Now this time it's just negative 6. There's no double negative going on because b is a positive value, so it's minus 6 plus or minus square root of 92, because we've already worked out that b squared minus 4ac bit, so we can go straight to just having a single value there. And on the bottom, 2a means you've got 2 times 2, which is clearly 4. So we've got x equals negative 6 plus and minus square root of 92 all over 4. That's going to split up into 2 solutions, one of which will be negative 6 plus root 92 all over 4. The other one is negative 6 minus root 92 all over 4. You do both of those things on the calculator. This one here comes out to be 0.8979 and a whole load of other digits. This one here comes out to be negative 3.8979 and a whole load of other digits. And then if we round those, this time we're rounding to 3 significant figures. So 3 significant figures means 1, 2, 3. And we're using this one here to help us round. So we're going to have 0.89. That 9 is going to make the 7 go up. So that's going to be 0.898. And this one here, if you round that to 3 significant figures, this one, that's your first significant figure, second, third. And that 7 will make the 9 go up and it becomes a 0 there. So it needs to be negative 3.90, right, for the 3 significant figures, and that's it. So now it's your turn to practice working on this. Please look at the layout and the structure of what your organisation's the key here, and making sure that you work your way through these questions.